So hi everyone, in this video we are going to discuss about binomial coefficient. So last time we have discussed about the permutations and the combinations, and today we will discuss about, as I mentioned, the binomial coefficient. So before we proceed, let us first discuss the factorials first. So for instance, if we have any positive integer n, so if we take the factorial of n, that would be equal to n times n minus 1 times n minus 2 until it reaches 1. Okay, so we are basically applying here the rule of product, right? So if we have 1 factorial, so it will be equal to 1. If it is 2 factorial, it will be 2 times 1. And if 3 factorial, it will be 3 times 2 times 1. So by convention, if we take the factorial of a 0, it will also be equal to 1. So what about for the binomial coefficients? So if we have, or for any integers n and k, wherein k is greater than or equal to 0 and less than or equal to n, so we are also using this notation n taken a and taken k, which is equal to the n factorial divided by k factorial times n minus k factorial. So if you remember in our previous topics for the combination, right, this is also the same exact formula, except that we were using r instead of k. Okay, so but for this specific topic, we are going to use k instead of r. So as an example, if we have 4 taken 2, so that would be equivalent to 4 factorial, since the n here is 4 and the k is 2. So 4 factorial divided by 2 factorial, since our k is 2, and n minus k, that would be 4 minus 2, so 2 factorial. So if we evaluate this, this will be 24 divided by 2 times 2 equals 6. What about for this example? 3 taken 0. So that would be 3 factorial divided by 0 factorial and times 3 factorial. So how did we arrive to this? So since the n is 3, so we have 3 factorial and k factorial, that would be 0. So 0 factorial, and n minus k, that is 3 minus 0, which results to 3 factorial. So that would be 6 divided by 1 times 6. So as we have discussed earlier, the 0 factorial is basically just equivalent to 1. Okay, and this results to 1 then. Now, again, we have this notation for binomial coefficient, the n taken k. So this would be interpreted as the number of ways to choose a subset with k elements from a set with n elements. So assuming that we have 10, we have a set containing 10 elements and we want to take 6 elements. Okay, so that would be the k. That would be 10 taken 6 or n taken k. And well, this notation, n taken k, is equal to the number of k element subsets that can be formed from a set with n elements. So let's have an example. So suppose we have the set S, and the set S contains these elements. We have a square, a green circle, a heart, and then a star. So we want to take a subset of S. So what are, or how many ways can we select 2 elements from a set S containing 4 elements, right? So these are just some of the examples that you can select. So you could select a square and then a circle, a square, and then a heart, a square, and then a star, or maybe a green and then a heart, and then a green circle, and then a star, and then the heart, and then the star. So note that we don't care about the order of the elements that were selected, but we are just going to select two elements not pertaining to the order. So that would be 4 taken 2. And if we use the formula of combination, which is n factorial, so in this case, since n is equal to 4, we have 4 factorial divided by the k factorial, so that would be 2 factorial times n minus k, or 4 minus 2, which results to 2 factorial. So this will be equal to 6. And 6 is the number of subsets of S with 2 elements. As you can see here in the example, we indeed have 6 na subsets with 2 na elements taken from the set S.